So today is the 17th. We are going to be talking about limits involving factoring. This is a level 3 and level 4 skill. Today we're only going to work on level 3 things though. Sorry. The difference between level 2 and level 3 is that level 2 already comes factored. So let's say I have the limit as x approaches 2 of x plus 3 times the quantity x minus 2 all over the quantity x minus 2. This problem is already factored, right? We have our binomial factors, and then we can continue on to cancel out what will make this not, or what makes this have a denominator of 0. So we'll be able to cancel out and then evaluate. So these problems in level 2 are already factored. For level 3, we instead get the limit as x approaches 2 of x squared plus x minus 6 all over x minus 2. So this level 3 needs to be factored. This level 3 is just this level 2. These two are the exact same problem. Exact same problem. This is just factored already, this is not. So we're going to need to make a level 3 problem look like a level 2 problem. That means factoring out the greatest common factor, using your X method to find the factors of the quadratics and then cancel and evaluate. Okay? I'm going to give you some steps. Am I going too fast?
No.
Okay. Can I move down right there at least? No? Yes? No? Right there? Yeah, that's a minus 6. Good? Okay. All right, so here are some steps or guidelines for your level 3 and level 4, gentlemen. Last week when we were working with IXL, we were working with finding the greatest common factor. That greatest common factor can be a number or it can be a variable. So your first step is going to be, or not to be, find the greatest common factor of the polynomial. You have to do this for both the numerator and denominator. This will be a number and or a variable. You may not even have one, but that is the first thing you need to check for. You need to check to see if it has a greatest common factor. Are there any questions on any of those vocabulary words? Thank you. Number 2, you're going to factor any quadratics. But Miss Santana, what is a quadratic? That is a fancy word. A quadratic is a polynomial with degree 2. I still don't understand what that means, Miss Santana. Can you give us an example? Of course. So an example would be x squared minus x minus 6. This is a quadratic because the degree of the polynomial is 2. Can I move down? Can I go right there? What? Dude, you weren't here yesterday. You got a break. After this step, after you have factored out the numerator and denominator, you now have a level 2 problem. So now we can just go on with the level 2 problem and cancel any common factor. It could be 1, it could be 2, it could be a million. If there are multiple common factors, you want to cancel it out. Multiple common factors, cancel them out. You're going to rewrite the limit then? And then evaluate. What does evaluate mean? We don't solve because there's no equal sign. It does start with an S though. Substitute. What? Questions? You move it up? Is anybody still copying up here? You sure? Right there, good? Okay. When you're done copying that down, take out the example sheet. Annie? Are we good? Does everybody have this? Nobody's responding? Pass it to Anna E, please. All right. What is my expectation to write your name on the board?
Oh, you gotta ask.
What does it literally say?
Yeah, but that's like those models right
That for real. It looks like a line of birds. Hold on. Oh, shit.
Well, I
Is it
almost
time?
said
Can I
something.
go to the bathroom?
No. Yes. Okay. Are we ready?
What?
Okay. So let's go through the steps. We need to find the greatest common factor, if there is any, of the numerator and denominator. No. Nice try. Do these two terms have anything in common? X. They both have an X in common. Ooh, that's... Okay. Alright, and then we create our... Is that the only thing they have in common? Do they have any numbers in common?
1.
Yeah, but we don't need to write the 1. Anything other than 1?
No.
No. Alright, so let's write our binomial. What goes on the inside? Do you remember this from last week? Ooh, this is why we did factoring last week. X? Nope, not minus X. Minus 1. Remember, you're asking yourself, if they both have an X in common, I need to figure out how many more X's I need in the parentheses. How many is here? 2. How many do I have here? 0. There's literally 1 here. So that means I need 1 more here, right? I already have an X here. So you're basically dividing. X divided by X is what? Nope. 1. X divided by X is equal to 1. You can't see it. Okay? Questions? Do I have any common factors in the denominator? No. So I just do that. What's my next step?
That's it?
Factor quadratics. Do I have any quadratics? No. How do I know?
So there's no one.
Because what?
There's no quadratic.
But how do I know it's not quadratic?
No numbers.
There's no 2. There's no square. So then what's next?
Distribute.
No. No, I need to address that though, because there are students that will distribute. If you distribute, you're reversing any factoring that you did, and you're going to have to do it all over again. Okay? Yes, cancel it out. I don't know who said that, but thank you. And then you rewrite.
Thank you.
How'd you get -1, Rafa?
0 minus 1. And this is negative. I mean, 1.
Yep. So we're evaluating the limit. Questions? Questions? Are we sure? Are we ready? Okay. That was very aggressive. You ready now or no? Yes? You know I'm trying to teach, right? I'm not talking to you.
Like a week.
Yeah, on YouTube. I was done, and then now I'm waiting on YouTube. Are we good? All right, next one. Numerator. Is there any factors that are common? Are there any factors that are common? No. There are no x's in both of them. There are no multiples in both of them. So we'll just leave the numerator alone. Denominator. Are there any factors in common? Sorry, there should be an x here. My bad. Well, are there? No. This one does not have anything in common with the rest. Every single...
13x.
13x, yeah, sorry. Every single term has to have the thing in common. So can I factor out an x? No, because 42 doesn't have an x.
Oh, I thought it was you.
Oh. Like, no. I wonder if I can do that. No, you can't. I'm teaching. Okay, now, is this a quadratic?
Yeah.
Yes, so I need to use the X method or box method or Batman or whatever. 42 goes on the top, 13 goes on the bottom. What are the factors that will add to 13? 6 and 7. Hint. 90% of the time, one of the factors will be there.
90%?
Yeah.
Why not 100?
Why not 100?
Yeah.
I don't know. I don't deal in absolutes.
Who made math?
Oh my gosh.
Who made that?
So what's that mean about my factors? X plus 6? Gentlemen. Questions? Now what? Cancel. When we cancel out the numerator and there's nothing left, what goes in the numerator? 1. 1 over.
Over.
Oh, sorry. Let me rewrite. Where am I going to cross it out?
I would do that backwards.
So we have the limit as x approaches -7 of 1 over x plus 6. I don't know who's next. Who's next? And now what? Now what?
Plug it in, so value.
Substitute. Evaluate. 1 over -7 plus 6, I think will give me -1. No?
Let me say, that's it.
Yeah, that's it. Snaps or hands? Thank you for the snaps. Thank you for the snaps. Yeah, but don't flip it.
You want it? Where can I get it from?
Yeah, don't flip it.
Right here.
Where's the -7 come from?
Right here.
Yeah, where did that come from?
Right here.
Oh.
Okay? See it? Tiffany? Okay. Okay, go to the next one.
Yeah.
Are we sure? Oh, yep. I'm waiting. Do you have a question or you're just writing it down? Okay. Are we good now? Evelyn? Alicia? No? No? Okay. You sure? Okay. All right. Let's look at number 3. Greatest common factor. Does the numerator have greatest common factor? Rafa says no.
Wait, yes.
Rafa says yes.
You said, yeah, yes, yes.
It's yes? Elisa says no.
Oh, it's a no.
Matthew says yes.
You said there's a common.
Do they all have an X?
Yeah.
Yes, so they at least have an X in common. Is there anything else they have in common?
No, that's it. That's all I got.
Incorrect.
Amen.
Can 6 be divided by 3?
Yes, yeah.
Can 45 be divided by 3? But yeah, you can. So you got to pull out the 3x. Okay? Does that make sense? No? Okay. So each of these things has an x in common. We got that, right? Now, can all of these things be divided by 3? Can 3 be divided by 3?
Yes.
Yes.
Can 6 be divided by 3?
Yes.
Can 45 be divided by 3?
So it's gonna be the same problem.
Yeah, it has to be the same. Like these two can't be 3 and this one not have 3. Does that make sense?
Yeah.
Okay. All right, and then I'm just going to finish my factoring. 15, I think. Right? Are there any questions on how I got that?
No.
For sure. Sure. It's not nap time. Wake up, sir. Thank you. All right, let's look at the denominator. Are there any common factors? No, so this just stays the same. Do we have a quadratic? Do you have a quadratic? Yes, we have a 2. Yep. So we need factors of negative 15 that add to be negative 2. You can't see that. What is one of them? Automatically, what should we know to be one of them? 3. And negative 5. Oh, stop. Oops. Question so far? Am I going too fast? Okay. It should be like where you were looking. You might like have to dig through them because there's 3 different papers. That it? Okay. Ready? Okay, what do we do now? Cancel. So we have the limit. Am I off screen?
Yeah, a little bit, I think. Are you? Yeah.
The limit as x approaches negative 3 of 3x, x minus 5. Oops, don't need that. And now what do I do? Substitute. So we have 3 times negative 3 times the quantity of negative 3 minus 5. I think I get, oh, move up. Okay. I think I get 72. Somebody do my math.
So you're, yeah, look, why'd you,
What did I do?
the X is the X.
Yeah, there are 2 x's. 1 x here, 1 x here. Every x. Yeah. Is this 72? Yes? No? Yeah. Erase them all, please. Thanks. Cool? Are you sure? No? Yes? All right. All right. So, let me stop.